Hello and welcome to another coding session. How about that? How about that? I bet you didn't expect that shit to happen yet again. It's almost every day, unless it's not. So yeah, today we're gonna continue working on this silly thing that we've been working for, I don't know, for five days. I think this is the 5th day, right? So, and on the previous stream, we implemented very simple OpenGL integration, right, for our project. So let's actually do a little bit of a cleanup. I'm gonna do clean FDX, which will remove my render doc, and I will regret doing that. I will have to download it yet again, but I have zero motivation to actually move this entire thing to a different place. You know what, I think I do have motivation because it's a single command. I'm gonna do something like this. I'm gonna move it to my software folder, right? So I'm gonna do git clean fdx, right? So that removed everything. And let's fetch the latest stuff, right? So because I did a little bit of a cleanup off screen, basically rewrote the whole project from scratch. I'm joking, I didn't. Yeah, so essentially I just like organized everything a little bit. So now we have a src folder and I put everything into src folder, and now we can try to build this entire thing. One of the things I did is basically I merged together the previewing and the rendering version of this entire thing. So now I can just do a preview, and here is the OpenGL example that we were doing, right? So the interesting thing about this OpenGL example is that it doesn't use any basically third-party bindings. We implemented all of the bindings ourselves, right? So right now we're using GLFW for cross-platform creation of the windows, and also OpenGL for cross-platform rendering. And we implemented a very small subset of the bindings, of the unsafe bindings that we are using, right? So an entire code is like 200 lines of code, and what it does, it just basically creates OpenGL context, just compiles a bunch of shaders and just generates this pretty picture, and all of that without using cargo, right? So, and that's basically what we have so far, right? But that's not enough. Our main goal is to render the video we generate in real time. Let's take a look at the video that we're generating. So let's quickly generate everything. So it's gonna take some time. So the way we generate the video is just we are actually generating raw frames and raw sound, and then using FFmpeg we just merge them together, and that creates the final video, right? So of course the entire process is rather slow, yeah, after some time we should be able to take a look at the video, and here's the video. So as you can see, it generates the video and it generates the sound, but all of that was generated offline, right? All of that was generated offline. So, and that's the goal of our, you know, of our today's stream and our future streams, is to learn how to generate this kind of stuff online, right? Basically in real time. So we already have, you know, GPU accelerated rendering. And the last thing that we need to port this kind of thing to real-time rendering is the sound. So we'll need to integrate with some sort of a sound API. So I was researching what sound API would be sufficient to integrate with. I tried ALSA, and I think ALSA, like basically directly working with ALSA in 2021 is kind of completely infeasible. Right, because majority of the distros are using Pulse Audio, and Pulse Audio, by the way, is literally X11 for sound. It's actually quite bizarre. Right, it's literally X11 for sound. So we can even take a look at this kind of stuff. So where is my stuff? Why am I reading chat? Just a second, I need to close the chat. So let me see. So basically you have X11, right? So X11 server, you have X11 server, so it's gonna be X11, and I suppose it uses frame buffer. I think it is rendering everything into the frame buffer, right? FB, and then your application, your app, connects to the X11 server via some sort of a wire. Right, so usually it is Unix domain socket, right? If I'm not mistaken, some sort of a Unix domain socket. At least on my machine, I looked into how exactly applications connect to X11 server, and that's literally Unix domain socket, which is basically file. So you just open that file and write into it. No, not really. Actually, you have to open that file via the connect syscall. And it's rather complicated, so it's not just as simple as opening the file. Right, so, and I'm not sure if it's actually frame buffer, maybe it's something else, maybe it's just like doing some more, you know, direct magic or anything. So, and basically Pulse Audio, apparently, I looked into how it works, Pulse Audio is the same level of shit, so, right, it's the same level of shit. So there we go. So you also connect to it via some sort of a wire. I don't know exactly what it connects through. Maybe it's also Unix domain socket, or maybe it's a memory mapped file stuff. But I don't know. So it's the same. It's kind of shit. And it basically works with ALSA like this, right? So, but the main thing of Pulse Audio, if I understand correctly, if you have several apps, it handles mixing for you, right? So if you connect two applications and they output sound, it will mix all of that and output that to ALSA. ALSA, as far as I know, also has its own mixing options, but Pulse Audio tries to basically, you know, fill the place as X11, so basically everyone connects to that central place and everything is managed from a single place. So that's basically what's going on here, and a lot of distros use this kind of thing. So we may try to depend on Pulse Audio. So it doesn't really mean that it's going to be sort of locked into Pulse Audio and there will be no option to use anything else. We may try to maybe abstract that away, so in the future it will be easier to port to a different sound API, and we'll definitely need to do that if we want to make our application work on Windows, so there will be some sort of abstraction layer. Right, so, and I looked into API of Pulse Audio and it looks relatively simple, so we can integrate with this entire thing and see how it goes. See how it goes. Does anyone have any on-topic questions? Pipewire versus Pulse Audio. I have no idea what is a pipewire. Pulse Audio is crap with all Serious Sounds app. Well, good thing that our application is not a Serious Sound app yet, because it's unfinished. Why not using ALSA? I think I already explained it, right? So I literally explained why I don't want to use ALSA right now. Maybe later we can add support for that, but I'm not sure, since we're writing sort of like a throwaway code which we use to explore the idea space of the application that I'm developing. I don't think it's that important to like rat hole about specific API, if you know what I'm talking about. Does it make sense? Right, so because our goal is to explore what kind of other patterns, visual and audio patterns that we can generate. And since I'm the only one who's doing that anyway, it's important for that application to work on my machine, right? Because you're definitely not going to be running this application on your machine because you don't give a shit, right? So, and I do give a shit. And I want to explore what kind of other patterns and sound, you know, video and audio patterns I can generate. And once I find something interesting, I can solidify the source code and make it more cross-platform and more portable and more stable and more robust and so on and so forth. Does it make sense? Does it explain? So you see, the situation quite often is not as simple as A is bad, B is good, let's use B. Situation is complicated, you know, life is complicated. Does anyone have any other questions maybe about what we're doing right now? Okay, so let's take a look. I never actually worked with Pulse Audio API, but I found a pretty cool thing. pa-cut simple.c, I think that's the thing, and it's a part of the code base of Pulse Audio. So Pulse Audio Codebase actually ships with this very simple piece of code, and what it literally does, if I understand correctly, it basically accepts raw. Oh yeah, it literally accepts raw sound data, and just outputs it to the Pulse Audio device or Pulse Audio sync or something like that. And as you can see, it's actually rather simple, right? And it even has the name simple in the functions, right? It's yet another case of a simple API. Yet another case of a simple API, right? You know what, guys, I'm talking about? You guys know what I'm talking about? Because it's like endemic to all of these like things. There's usually like a common, like a usual way of doing things, but then the authors of APIs realize that it kind of sucks and overcomplicated, so they create the simple version of the API. Right. So it's kind of funny. Like X11, as far as I know, has that X11 manual. So if you take a look at the X11 manual, so there is a HTML version. So is there index of function? Okay. So there is a function xCreateWindow, right? So if you take a look at this thing, it has an xCreateWindow, and the xCreateWindow actually has a lot of attributes, as you can see. And you have to provide all of them if you want to create a window. But then people realized, well, that kind of sucks. That's a lot of arguments and you don't care about some of them. And there is a function called xCreateSimpleWindow. Right. So this is one of the case of the, like, you know, simple version of the API. Curl has a similar thing. It has easy API. Right. So at some point, libcurl developers realized, well, the usual way of using curl is kind of overcomplicated. Let's create an easy version. So when using easy interface, you init your session to get handle and so on and so forth. You see, so there's a simple and easy version. And apparently Pulse Audio has a similar situation. So now I have 3 examples that actually do that. I don't know why I find it so funny. Like, am I the only one who find it funny, like when libraries do that, right? So they have the API, then they realize, oh, it's kind of crap. Let's actually make a simpler version. Anyways. So, let me see what we can do. I wonder if we can even compile this entire thing. Can I download this shit? I mean, copy-paste it, if you know what I'm talking about. Let's copy-paste it. pa-cut simple, not sample, but simple.c. There we go. Simple.c, and if I try to compile this entire thing, I'm not even sure where I want to put it. Yeah, let's actually keep it in here. pa-cut simple, and I'm gonna move this entire thing in here. And maybe I want to create like a simple make file that will compile this thing for me, because the compilation command line is going to be rather complicated, right? The compilation command line is going to be rather complicated. Not really that much complicated, but I mean, you know what I'm talking about, right? So what flags do we need? I don't think we need too many flags, but we'll need something that is provided by package config. And the question is, does package config even have anything to Pulse Audio related? So it's going to list all, grep pulse. What do we have in here? So we have a lib pulse. Okay. So lib pulse, and let's take a look at the flags that you need to put in here. So d reentrant. Maybe it is important, maybe it is not, I don't know. So, and the libs. Okay, so you just link with this entire thing. I'm not really sure what underscore reentrant does and why Pulse Audio wants it to be this way, but I'm gonna provide that anyway. Speaking of, by the way, so I forgot to provide the source code to the project in the description, right? So you can find the source code in here if you're, of course, interested in that. If you're one of those rare people who's actually interested in programming and like to read someone else's source code, as much as I do that quite often, all the time. I rather prefer reading someone else's source code rather than someone else's documentation, right? So, and in that case, if you're one of those people, I'm provided the source code for you because I like you. I like people who like to read other people's code. Okay, so let me see. So this is going to be C flags, and it's going to be lib pulse, and we're going to compile this entire thing like that. There we go, and let's actually copy paste this entire thing. There we go, and it's going to be libs. Look at that, look at that, and now I can try to compile the entire thing, and is it gonna compile? It did not compile because we have undefined reference to PA simple drain white free. So maybe we didn't link with something important. Wait a second, where is the list all? Okay, that makes sense. So you probably need to link with libpulse simplified synchronous interface. Okay, so maybe that's exactly what I need to do in here. Please, neighbors, please don't start this shit yet again, please. Please, I fucking beg you. I want to have like a calm stream at least once. Okay, so it seems to be compiling. I don't even need a non-simple version. That's what's cool about all of that. You don't even need non-simple one. Alright, so if I try to run this entire thing, prepare your ears, and you won't be able to hear anything, I think. Okay, what if I type something in there? Oh, I cannot type anything in there because I'm in Emacs. Emacs is a piece of shit. Okay, so PA-cat oh well, I need to go there. Alright, PA-cat simple. Right, so it's listening to input. What if I do something like, and okay, invalid argument. That is very interesting. So the question is, can I just take my raw sound file and play that sound file with PA cut? So I'm gonna... Why the fuck am I doing that? Holy shit. I forgot how to use headphones, I'm really sorry. And I suppose I can do something like... maybe I need to read how this entire shit works. Right, so does it accept... Yeah, it accepts the file. Yeah, you can just provide the file in here. So output PCM, prepare your ears. I really apologize for that. Ooh. Okay. So... I didn't do that intentionally. So you see, working with sound APIs is rather dangerous. I warned you, by the way. I warned you, right? So because I know that working with this kind of APIs is really fucking dangerous. Oh, I know why. I know why it is like that. Because it expects a completely different format. It expects 16LE. Oh, fuck. Okay, do you have like something like F32LE? Because that's basically the format that we're using in here. So F32LE. Alright, so let's actually recompile. No. That's really fucking scary, mate. That's very fucking scary. Okay, so it doesn't even have that. Really? It doesn't have that. It's incapable of doing floating point formats. Disgusting. Okay, so let me see. Include pulse, and it's gonna be a simple S16LE. Okay, so it doesn't even have them. Let me find the place where it is used in here. So here are the BE and some other stuff. Oh, it's called float. Of course, signed signed 16-bit integer is called S16, but float is not called F32. No. We don't care about consistency of our naming. It has to be called float. Okay, whatever. Doesn't matter. Sure. Whatever you fancy. So it has to be float. Okay, so what do we do in here? Okay, so at least now it compiles. Okay, I'm gonna actually bring the sound down way more, right? So hopefully everything is gonna be fine. We recompile the entire thing, so I'm gonna actually put -B to ensure that we recompiled everything. So, and now I'm gonna try to play the sound. I actually gonna keep my hand on the volume. Okay, that's already closer to what I would expect. The frame, the sample rate is incorrect. I can clearly see here that the sample rate is incorrect. Where was that? Okay, so this is a useless shit. So, oh yeah, sample rate is definitely incorrect. So we're using completely different sample rate. It's gonna be 48. Okay, so that makes sense. And now, if I try to play this entire thing. Okay, so I think it also assumes, yeah, 2 channels. All right, so let's actually make it 1 channel. So it's kind of funny how the assumptions about the format are completely incorrect. We're using completely different format, completely different sample rate, completely different amount of channels. It's just beautiful. So it's just like, yeah. Anyway, let's try to compile the entire thing. And now, so it, yeah, I hope it wasn't too loud, right? What if it's a find, or whatever. Okay, so, and this is roughly how it's supposed to sound, right? So if we go somewhere here, so that's basically what's supposed to happen. Yeah. This entire thing is working, and what's interesting here is that it basically allows us to generate this kind of sound in real time, which is kind of fucking cool, isn't it? And the simplicity of this API is actually astonishing, in my opinion, because it just has a PA simple write, and you just give it the buffer, and it just writes that buffer into the sync or whatever. So yeah. Make sure that every single last drop of sample is drained. So, yeah, I think we can use that. I think we can fucking use that, mate. That's pretty cool. Okay, so I really like the simplicity of this API. It is truly simple API. It is what it's advertised. It wasn't too bad this time because I was doing a different thing. All right. So let's do a preview, right? So here's the preview. So, and we're gonna continue working on our preview thingy, right? So on top of generating some visual effects in here, we're gonna be also generating a sine wave to test the Pulse audio integration, right? So we're gonna be doing that. Did I put a marker on my VOD? Yeah, so it's quite important. Like, I want to also put a marker in my VOD to warn people in the comments who's gonna watch this video on YouTube, right? Because I think it's pretty important, because nobody expects this kind of shit. Though, I warned everyone beforehand, so maybe I don't even need to warn in the comments. But maybe I will, just in case. Okay, so here is the OpenGL stuff, and yeah, let's introduce the Pulse audio. Where are we going to be putting the Pulse audio? I think I'm going to put it somewhere here. So it's going to be extern, and what kind of functions do we need in here? PA cut. So the first thing we do, we need to have a structure for PA simple spec. PA simple spec. Let's find where this thing is defined. So it's pulse something, something. Is this gonna be like NP CPP? I have no idea what it is. Okay. Now let's actually find this entire thing. So where is the definition of the structure? Maybe I should have actually said something like this, because that's how usually people, yeah, there we go, I found it. This is how people usually define the structures, and I like that the structure in here is extremely simple. So we'll need to make sort of an analog of that structure. Right, so an analog of that structure. It's actually really strangely defined. Why would you define it like that? Because it will be padded anyway to a particular size, if you know what I'm talking about. Right, let's actually go to preview, right? So, and I'll have to probably put this thing in here, right? So, struct PA sample spec, right? And as far as I know, we have to do something like a wrapper C, if I remember correctly, right? So something like wrapper C. Maybe we need to open the Rust reference API so I can, you know, constantly check it out. Oh, by the way, I also am going to put the link to the source code to this thing in the description if you're interested. PA-cat simple.c. It's an MPD client. I have no idea what is MPD. That allows visualization of music. Cool. So Rust reference. Very interesting. Visualization of music. Really fascinating. Thank you so much. So wrapper. The type, system type, layout. Yeah, you do it like a wrapper C. So I'm not really sure how you do stuff with this kind of thing when you have a PA sample format. Right, so where is it defined? Is that a type def of some sort? It is not a type def, it's an enumeration, right? And as far as I know, in C, enumerations are just like integers. Right, so that means I can just use cint for this thing. So maybe we also need to bust out Rustanomicon, I think. Let's actually bust it out and let's take a look at what we have in here. So enumeration, do you have anything about enumeration? Data layout, wrapper Rust. So I think it has to be somewhere in FFI, I'm pretty sure. Right, so FFI, and do they say anything about enumerations? Okay. So Rust guarantees that the layout of struct is compatible with the platform representation in C only if wrapper C attribute is applied. It can be used to lay out struct member without padding. Wrapper C can also apply to enumerations. Okay, so that's pretty cool. That means I can basically take this entire enumeration, right, and say wrapper C, and it's going to be correspondent to you know, whatever you have in C, I suppose, right, except an invalid thing, but I'm not really sure how to do like this invalid thing in here. So, and sample max, the maximum limit of valid sample types or something like that. I don't know, I think it would be easier to just like do cint, right, and for some of these constants define something else, but maybe, I don't know. So is there anything, a special case enumeration is null pointer initialization, calling Rust code from FFI panics. Okay, so notice that they're really bad idea to use an empty num as FFI type. The compiler relies on empty nums being uninhabited, so handle values of empty huge for okay, so maybe it doesn't really matter that much. Maybe it doesn't really matter that much, so let's just copy paste this entire thing and just enjoy our lives. Just enjoy our lives. So I'm gonna put it in here. So yeah, here is the enumeration. So this is gonna be a wrapper C, right? Wrapper C. And I wonder if you can just literally do that in enumeration in Rust. Let's actually find out. I know nothing about Rust, right? So I'm only learning, okay? So I'm only learning. So let's do something like build. And what do we have in here? Expected, yeah, you cannot just do it like that. You cannot just like assign this thing in here. So, and that's what makes me worried a little bit. So, that's what makes me worried a little bit. So as far as I know, you can cast enumerations to integers. rest enumerations to integers. Okay, Rust C enum FFI. Let's actually Google up. Is there any like you know, established conventions on how to do this entire thing? We need to put like a sub mod to prevent backseating, but backseaters actually stepped up their game. They're now subscribers. Okay, that's very cool. So okay. Presentation I32. So there's too much stuff in here. Unsafe code guides. Okay. So layout of Rust enumeration. Some parts of this section will decide categories of enums. Empty enums, enums the no variant will be fieldless enums. The simplest form of enum is one where non-variants have any fields. Such enums correspond quite closely to with enums in C, though the importer presumably. Fields enums may also specify the value of their discriminating explicitly. But that's exactly what we're doing, right? That's exactly what we're doing. We're doing -1. Is that because it's negative and you cannot do negative? Representation annotation accepts on enums. Compatible, C compatible layout. It's kind of strange, right? So if I did C compatible, right? If I did C compatible, right? So that should just work. So let's actually see what you know, it says. Found in the condition comment that doesn't document anything. Okay, whatever. Let's remove this entire thing. Right, let's remove this entire thing. I don't think it's useful. I hope I didn't remove anything. God damn it. So I need to be super careful to not remove anything. You can enable emotes only mode, but even then we'll find a way to backseat. Well, I mean, I can ban everyone. So what do we have in here? Okay, so let's actually try to compile this entire thing, and okay, it is working. All right. So it seems to be working. So it was about something documentation or whatnot. And also, if I remember correctly, non-camel case types. So can I just go ahead and allow this thing here? There we go. Okay, enum is never used. Okay, so that's precisely what I wanted to see. Hopefully that will work. And now I can try to define the rest of this stuff. Right, so this is going to be wrapper C. Right, so this is a wrapper C. Then we have a format of this entire thing. A rate. I suppose we can do I32, and the channels is going to be what's it, I8? It's a U32, right? It's like a U32, and this one is U8, which is a really strange way of doing that because it's going to be padded kind of weirdly, but it is what it is, and it isn't what it isn't. All right, so we have everything that we'll probably need in here, right? So you have a first warning, E032 Eric, please stop backseating. You have a first warning. After the second warning, you're permabanned. Okay, so what do we have in here? So this is the format. It's actually wasn't called T, right? So maybe we don't even need to call it T. Okay, looks cool. Looks cool, looks cool. PA-cat.c. Alright, so maybe I'm gonna actually start in a separate thingy. So this one is gonna be like this, and we're gonna create another one here. PA-cat. I really don't want to ban people, but you're really ruining my my mood today. So PA simple. What is PA simple? PA simple. Okay, so it seems to be, it's an opaque. Okay, that's actually pretty cool. I really like opaque stuff. Right, because I don't have to deal with this kind of bullshit. Right. So this one is going to be PA simple, right? So it's going to be PA simple, and it's going to be C void star like this. So not really star. Right, cool. So now the next thing we have to do, we're not doing anything particularly special in here. We need to PA simple new. Okay, let's actually see what this function is all about, right? What's this function is all about? That's a pretty huge function, not gonna lie. But maybe it is worth it. So there's a couple of specs and stuff like that. Majority of these things, we probably won't need them for a simple case, right? So, and maybe we're gonna mark them as opaque pointers, because as far as I can see, majority of them are just set to null anyway, right? So it doesn't really matter. So that means I'm gonna just make them opaque to some extent, right? We're gonna just make them opaque to some extent. So server name, yeah, it's literally x11, as you can see. As already said, it's just basically x11. So it's gonna be like that. This is gonna be like that, and this is gonna be the error. PA simple. What does opaque mean in this specific context? It means that you don't know what's inside of the structure, right? So it's private to some sense. Right, so let me actually show you what I mean by that. So you have a structure like this, right? And it has a bunch of fields, right? It has a bunch of fields, right? And if you have a pointer to the structure, you can still access those fields like so, right? So I wonder if I can even try to compile the entire thing here. The GCC main.c, and I'm gonna just run this entire thing in here, right? And it's segfaulted, of course. Maybe I didn't even have to run it because it doesn't really matter, right? Of course, this entire code is going to segfault because you're dereferencing the null pointer. It's very, very bad. I know all of that, but that's the point of the not the point of the explanation. The explanation is whether this entire thing is visible from the compiler point of view or not. So this entire thing is in fact visible, right? So you can always actually declare sort of foo up front, right? You can declare it up front, and you can work with the pointers to foo. It's gonna be totally fine. You see, I never actually defined foo, right? So I just declared, it said that there is such thing as foo, but it's not defined here, it's defined somewhere else. And I can even create a variable of the type foo, and I can take a pointer to it, well, I mean, define a pointer to this thing and assign it to null, right? And it still compiles. Look, 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 this entire thing still compiles. Even though we don't fucking know what is foo. We don't fucking know it, like, but it compiles perfectly. Because what you're doing essentially, you're saying that I have a pointer that points to something that is foo, but since I never try to access what's inside of it, doesn't really matter. Compiler doesn't care because the pointer is just like a, an address in the memory. So it just says somewhere there is something. Okay, I'm really glad that somewhere there is something. So that's fine. But if you try to do something like this, now you're not just saying that somewhere there is something. You say somewhere there is something that contains X, but the compiler doesn't know that, right? You see? The compiler doesn't know that, and this is quite often used by the designers of APIs of libraries. So essentially, you can have a bunch of functions that's, for example, create foo, right? And they return you a pointer to foo, right? Then they also have a destructor, like destroy foo. Right, they accept this entire thing and they destroy it. And then, for instance, you can render or like print foo, right? And there we go. So at any point, you can quite easily create foo, right? You can then print foo, and then you can destroy foo. Notice how nowhere in here you actually need to look inside of foo. You never need to look inside. So you never need to know what is foo. You only need to know that there is something called foo, and these kind of functions, they accept something called foo. But you never need to know what's inside of it. You don't even need to know the size of this entire structure. You don't know, it's just a pointer for you. It's an opaque structure. That's what it is. It's an opaque structure. Right. So the only thing you need to know is that to get foo, you have this function. And the implementation, the place where these functions are implemented, they do know what is foo, but you don't. So you don't have to worry about that. Can you basically compare this to interfaces in C#? You can compare anything with anything. It's not useful. So it's basically hide away implementation details. Probably. But unlike abstraction features in higher level languages, this entire thing have very specific technical implications. We're not just talking about abstract interfaces, factories, and some weird unicorn things in the sky. No, we're talking about address in a memory and whether you know the size of the chunk of a memory this address points to or not. We're talking a very specific low-level thing here. So that's a very important distinction in my opinion. So basically what you're saying in here is that you have a very specific address in a memory, right? Very specific address in the memory. You don't know the size of it, but at the same time, you don't need to. So this entire thing has a very direct translation to assembly. So this entire thing have a like just precise direct translation to the machine code of the machine you're running in. All of these abstract shit, interfaces, factories, beans, whatever the fuck people use these days, it doesn't really have to, it can translate to all sorts of crap. This entire thing has like a very specific, like, yeah, this is how assembly would look like. So, yeah. So that's the main difference, I suppose. Does calling ++ cause problems in this example? Finally, this is a good question. I have no idea, actually. Holy shit, somebody asked a good question. Right, so, yeah. You see, because if you don't know that it has very specific technical implications, you wouldn't even think about such question, right? You never would think about such question in case of a C# interfaces or something like that, because it doesn't have any specific technical implications. This thing does. And that's what's important, and that's what's cool. Okay, so it basically equivalent like +1 or something like that. So what will happen? I think it will complain. I'm pretty sure compiler has to complain. Yeah, so invalid use of undefined type. There we go. So since it doesn't know the size of the structure, it doesn't know by how much it needs to increment that address. Yeah, that's a very good question. Thank you, Gibble. Finally, I'm really glad when people actually listen to me and just ask like informed questions. That's actually super cool. Thank you so much. All right, so yeah. So I suppose what you'll have to do, like you need to know the size to perform any sort of pointer arithmetics. But since you don't know the size, there's, yeah, pretty cool. So that's what we usually mean by opaque structures in C, right? So you have a structure somewhere, you know where it starts, you don't know the size of it, but you also know the procedures that do know size of it. So you can just you delegate a handling of the structures to those procedures and never care about the size of this entire thing in memory. Beans also have some translation to machine code. Everything in programming world have some translation to machine code. The question is whether it is useful for you to know about exactly what's going on or not. In case of beans, it's not useful to know that. In case of C, it is in fact very useful to know that. So, okay. So let's continue actually like defining this entire thing. So here's going to be a procedure like in here. And it's going to return, I suppose, the mutable pointer to this opaque type, right? As you can, this is literally what it does, what I just explained. We have a constructor that constructs this opaque structure and gives us the pointer to where that structure begins in the memory, right? And we're starting to work with this entire thing. Okay. Let's actually start doing this kind of thing. This is going to be the name. Yeah. So PA stream direction. This one is rather interesting. Right. So, and it's not even defined in here. So it's a sample. I should probably look at the sample. What the fuck is this inclusion cards? Why did they put foo in there? I mean, it's fine. It works, I suppose. So stream direction. Okay, so there's no stream direction in here. Right. So this is going to be something like this, right? And here's another case of you know, enumeration of our nation. So preview our ass, more like preview my ass. Am I right? Oh, I'm sorry. So, can I just put this thing like in here? I think I should be able to. So it's going to be so. There we go. Okay. PA stream direction, and so I'm not quite sure if I want to put T in there. So I think I should be able to put T, like not put T in here. I don't think it matters. It can be changed at any point anyway. I wish my C++ lecturer spoke as casual as you. Well, your C++ lecturer basically have no choice, right? They probably can speak, but they just have no choice because they are in a very formal environment. Here I am in a very informal environment, and furthermore, in my settings I even marked my channel as for mature audience. So that means there will be swearing in here, and which should actually warn you before you join the stream that this is a stream for mature audience. So I do have a choice to, you know, be more casual. Your lecturer probably does not. Otherwise, they will be basically fired from their job. It is what it is, and it isn't what it is. It's not. So we have a bunch of shit in here which we don't really care about. So I'm probably gonna mark them as opaque pointers, right? So we don't really know what they are, so I don't really care about them. So this is gonna be PA channel map. Mutable C void and okay. So this is a constant pointers. This is the constant pointers. So there's some sort of a buffer. And error. Okay, so it means here we're going to be accepting the mutable C int. There we go. That's a pretty big, huge, juicy function. Look at it. Look at this big, juicy function. Let's try to compile the entire thing and see if it's gonna do what I think it will. Okay. So what do we have in here? No semicolon. So PA simple. So this. Oh, we already. Okay, so this one is not opaque, so I don't need to do that. So convert the attentive to uppercase. So okay, whatever. Rust allow attribute on whole module. How can I do that? Attributes. Okay. Okay, whatever. We'll have to suffer then. So generate metadata whole. Why doesn't it say that? I need to find confirmation in the documentation. Entire module, entire attribute. Let's call it like a module attribute. Maybe that will find a little bit better. Google is useless. Holy shit. So attributes, some module creates, conditional compilation, disable when attributes apply to the whole crate, but I don't need the whole crate. When attributes apply to a whole crate, and as far as I know, whole crate is just like a collection of all of the modules inside of a crate, right? I don't want to apply it to the whole crate. That would be stupid. I want to apply it to a very specific module. And when they apply to a module or item, the syntax is, okay, so notice the missing bang. So there should be no bang for the module. Okay, so that makes sense, but it's not particularly attribute, right? So, so it's kind of dumb. It's kind of dumb. Anyways, I guess we'll have to suffer. So because I want to do that only specifically on that module, but I don't want it to. And why do I even care? Like, for fuck's sake, it's yet another case of Rust just basically roping me into discussing something that is not fucking important. Why I find myself discussing a fucking style naming in the middle of doing an actual work? Why? Like, Rust is like always like that. Like, why do I find myself stuck in this useless loop of useless shit? It's just like so annoying. Why is that a thing in the first place? I shouldn't be wasting my time on this kind of stuff. Like, it shouldn't be a thing that I have to even discuss that. It's not even has to be discussable, right? So it's like not a thing to discuss. So whatever. It's just like I'm like, you know, I don't even know what to say. So it's like this language is literally designed to waste your time. It's designed to do that. Okay, so this is a PA simple. So and so this is going to be something like that, and let's actually go through all of these things, right? So let's go through all of these things, so the first one has to be null, right? The first one has to be null, and the name, I suppose you're using the name of the program, right? So you're using the name of the program. So let me actually go to Rust. I need the API docs, I suppose. I need some sort of API docs. So this is the Rustonomicon, this is that thing, and I need the API now. So let's actually close all of that useless crap, right? So this is going to Rust API docs. Let me find the API docs. So what we're going to have in here is essentially args. Let's find the args. So this is part of the environment. Okay, so let mutable args and std environment args, right? So that gives me that. So and the program should be located somewhere in here, or so. If I do args next, and I expect program name, right? So this is going to be expect program name. So then that entire thing should return me a string. As far as I know, args item is a string. Right, so let me take a look. No, I need to take a look at the implementation of the iterator. Yeah, item is a string. Okay, I can clearly see that. So it's a string, but can I convert easily the string into C string? Because I then will have to pass this entire stuff in there. So you can do from row, from vec unchecked, from vec with null, right? So something like that. Into string, you can convert that into string. So you can do new, and it takes something that is convertible. Okay, so maybe string is convertible into vec8, whatever the fuck it is. And where are all the implementations? So maybe it is. So navigating through all of this stuff is not particularly convenient, but the one thing I can do, I can just check if it will compile or not, right? And then I can unwrap this finally, right? Thank you so much. And is it gonna work? Is it gonna work now, yo? Right, so yeah, this entire part is not compilable yet. It is not compilable, and it is in fact compilable. It is in fact compilable. Would you look at that? Isn't that amazing? I think it's goddamn amazing. All right, so what I wanted to do in here now, Emacs. So name, right? I just wanted a program, program as PTR. There we go. So this is going to be program as PTR, and there we go. So PA stream direction. So PA stream direction in the case of a C program. In the case of a C program, what was that? Right, what was that? PA stream playback. Right, so this is going to be just a playback. And as far as I know, I'll have to also import this entire thing. So it's going to be PA stream direction. Right, and maybe I can just use something like this. Right, so import everything from here. So device, in case of a device, it's gonna be null, right? So device here is null, so I'm gonna be just, oh yeah, of course it has to be null mutable, I'm pretty sure. And this one is also gonna be null mutable, right? So string name, I can give it a name, right? So I can give it some sort of a name. So it's gonna be a string name, C string new. Playback, and we're gonna unwrap this entire thing, right? Right, stream name as PTR. So then we have a thing called SS. I have no idea what is the fuck is that supposed to mean. So, oh, it's a spec parameters. Okay, so now we need to fill this structure in. All right, so let's go ahead and do that. So this is the structure, very specific structure. PA sample format. In our case, we already established that it's going to be PA sample float 32LA, right? So PL32LA. The rate is going to be 4800, and the amount of channels is going to be 1. That's basically the format that we have in here. All right, so we have that, and so I also need to use PA format info, right? So this is, no, it's not the format info, it was sample format. Yeah, it was a sample format. Sample format. Okay. So, and in here, I'll have to take the pointer to this entire thing. Is that a constant pointer? Yeah, I can just take the constant one in here. So it's going to be this. So the rest of this stuff, is going to be null null. Okay, that makes sense. So this one is going to be just null, and this one is going to be just null. There we go. So in the error, we'll probably have to create a special thing for the error. Where is the error? It's just the integer in here. So we'll have to do something like mutable error, which is just cint, and this is going to be 0, and I'll have to give the mutable pointer to this entire thing, right? So this is going to be the error. Okay, finally, so you see how much you can do by just ignoring all that stupid shit that Rust wants you to care about. So you don't have to worry about that stuff anymore. Okay, so this entire thing may return you I suppose null. right? So that means I can check if s is null, right? If s is null, we have to panic. So we have to panic, and let's say that PA simple new failed, and we can get the reason why it failed, and the reason why it failed can be found through this function PA_str error. Okay, so we'll have to map that function as well. Right, so let's actually find this entire stuff, right? So where is that? It's a very simple function. Right, so preview, there we go, there we go. So here is the function, we'll have to put it in here. And it will return the row pointer or something. So, oh, by the way, oh shit, this is dangerous. Yeah. You need to use cchar in here. Yeah, it's quite important. So, and it's gonna be const cchar, and it will accept the error that we got from that entire thing, right? It will accept the error. And yep, now I should be able to do all of that, right? I should be able to do all of that. So it's gonna be like this. I provide the error, right? I provide the error, and I think I should be able to construct sister from that, right? I should provide the sister, and it's just like literally from pointer. Okay, cstr from ptr, right? From ptr. And no. So as str, Okay, so how can I compile the entire shit? So, oh my god, I'm in the wrong folder. Okay, so replace it, sure. I don't care. Whatever, just work. Okay, similar path exists self. Okay, so you want self, there you go, here's self, if that's what you want. I don't know why it is, it's important. Okay, so this is gonna be null. Okay, so what do we have in here? As str, found for the reference, no method to str, right? Is that what you want? What do you want? Doesn't implement display. Okay, so now I have to unwrap this entire thing. What else do you want? I have to go through all this crap. Okay, unsafe function. Sure, I don't care. Unsafe. Okay, finally, holy fucking shit. Okay, so what do we have in here? So now I need to actually link this thing with a specific thing. Right, so it's gonna name, so what was that? Lib, maybe pulse simple. I think that's what we have to link with, right? So that's what we have to link with. Okay, so it didn't undefine simple PA_str error. Okay, that one is actually rather interesting. So, is that because PA_str error is located not in PA simple? I think it's located in... Why do they have so many libraries? Pulsodio, what the fuck is wrong with you? Can I provide several of these things? That's a good question. Can I just do something like this? Okay, I can. Cool. So that's pretty cool. So let's now try to check if we manage to successfully create the you know, the connection or whatever the fuck it is. So we're gonna print ln created what is it called? Is that a handle? Is that a file? Is that a channel? It's a playback stream. Okay, created the playback stream. Right, and I'm going to provide it like this. It's going to be a debuggable thing, and we're going to just put s in here, and let's try to compile the entire thing. And I'm going to try to run a preview, right? And it created the playback stream. It created the playback stream, and we can see exactly the pointer. Right, I wonder if I can make it fail for whatever reason. For instance, if I provide a null instead of the program in here, what's gonna happen? Right, is it gonna fail because of that? Let's find out. So this is gonna be build, and then I'm gonna try to run it. Is it gonna fail? It still created. Look at that. It actually still created this entire stuff. How can I make it not work? Stream name. Can I provide null for this thing as well? Null mute. I think I know how I can do that. I can basically provide null for the parameters. Right. I'm pretty sure I will be managed to able to like break this entire thing if I provide null in here. There we go. Okay, so yeah, PA simple new failed invalid arguments. Okay, so that means it actually created things successfully. So yeah, there we go. Seems to be working. So we managed to successfully create the you know, the playback stream. So isn't that cool? Isn't that cool? I think it's pretty fucking cool. So does anyone have any questions about what just happened on the screen? So we just ported like a small piece of this application, and now they are trying to get like a latency or something like that, but I'm not sure if that's important, to be fair. I'm not really sure that's important. So then we use PL simple, right? What do we use latency for? Oh, they're using the latency to display it, so we're not going to be getting that. We're definitely not going to be getting that. And then they just use PA simple write, right? And they just write that buffer in there. And that's probably where we can start generating the sine wave. Right, so yeah, that's probably the only function that we need in here. We don't really need anything else. We don't really need anything else. Right, so PA simple. Rust. Module. So it's either very localized, but I suppose it's kind of, why is that what I have to do? Really? Wait, are you fucking serious? Do I have to do it like this? Don't fucking tell me that I have to do it like that. This is dumb. Don't tell me. Are you fucking serious? Ready? The function is never used, but it is used. Ah, this is because of that shit. Okay. Really? Okay. And if I put something like a comma, and it actually disabled, oh, this is so dumb. I really hate it. And like it keeps you like wind up on this useless discussion because it's not even that important. It's not fucking important, but why do you care about that? Holy shit. Maybe I do need to enable it for the whole application, but whatever. Okay. Any questions so far? There is a flag in Rust C to disable all these linting warnings so far, if any. But I don't want to disable all of them. I want to disable it on a specific module. That's the point. Like that's the point that chat cannot understand. I don't want to disable it everywhere. How can I say disable it on that specific module? I don't want to disable it everywhere. So all the solutions just disable on the whole crate. And again, why am I even discussing that? It shouldn't be a thing that I discuss. All right, so put this inside of module, but the documentation says if you put a bang, it applies it to the whole crate. And the whole crate, if I understand correctly, includes all of the modules, doesn't it? Or maybe I'm misunderstanding what is a crate. So we looked into the documentation. The documentation said if you want to apply it to the whole crate, put a bang. And then compilation uses flags in building environment crate. Okay. Right, let's make this. All right, let's continue. So we already ported one function, right? We already ported one function, and it successfully creates the playback stream, right? It successfully does that. So the next thing we need to do is to basically call PA write thing, right? So this is going to be PA write, and let me see. So where is that? PA write. So it's probably located somewhere. So this should be sample, right? So this is the sample. Grep or n. What do we have in here? So we need to port these things. So this is the preview, and let's take a look at that stuff. So that will return C integer, right? So it also accepts that playback stream. So I'm gonna do it like that. So the data is basically the pointer to the beginning of the buffer that we need to play in the playback stream. So it actually takes it as a void, which is kind of strange, but maybe it's fine because, yeah, the size of a single sample depends on the format that we specify in here, right? So that's the size of a single sample. In our case, it's going to be 4 bytes. So, and we'll probably have to take the pointer to the beginning of a particular buffer and then sort of cast it, like pawn it to a particular, maybe not even pawn it. If you're casting things to a void star, are you really panning it? You're not really panning, you're basically erasing the type information about the pointer. That's essentially what you're doing. So yeah, we'll have to do that anyway. So this is going to be the data. So it accepts the constant pointer to C void, right? So then it accepts the bytes. And I wonder if, well, size T is more of a libc concept rather than C concept, right? So I'm not even sure if we'll have that thing in there, right? So let me see. So where is the stuff? So I remember that if you have a C int, does it have something like C size? So that's the most important question. I'm pretty sure it doesn't, because yeah, again, size is more of a libc concept rather than the C one. Right? So I suppose what we can do in here is just to have C long, U long long, because I think that's the type of the size T on 64-bit platforms. I'm pretty sure that's what it is, and CU long long has to be like U64. Maybe just in case, I'm gonna just say that the bytes is gonna be U64, just in case, who knows. Right, so, and this one is basically C int, right? This is basically C int. Okay. Right, so we have a function that writes data into the playback buffer. And what we have to do in here is in a loop. We are basically organizing everything. So what's the buffer size they use in here? So buffer, they're using 1 kilobyte. We might as well actually do a similar thing. Okay. Maybe I'm not going to do that. So we're going to have some sort of a loop in here, right? So this is going to be the loop. And let's have a buffer. It probably needs to be mutable, right? It definitely needs to be mutable. So this is going to be simply an array of F32, right? F32. And the size is going to be like around like this. We might as well also zero initialize the entire thing. Right, 924. So here's the buffer. And we need to keep track of the global time, right? We need to keep track of the global time as we advance like the sine wave and whatnot. Oh boy. So the sample rate, where is the sample rate? So we can put the constant in here. So it's going to be const sample rate 48000. So this is the sample rate, but I want it to be usize. right? And I'm only gonna be casting that to something else as I do something in here. So this is gonna be the build. Sample rate as U32, as U32. There we go. Do we have anything else? Any other errors? Okay, so let me see. The amount of samples is the samples per second. So knowing that, we can compute the sample duration, right? Sample duration, and the sample duration is going to be something like this. So we have a single second, and we divide the sample single second by the sample rate, right? As f32, right? As f32. So this is a sample duration, and as we fill everything up, right, as we fill everything up, we're going to be advancing the time by that sample duration. So maybe because of that, we'll need to keep track of the time, right? So this is going to be f32, and we're starting the time at 0, right? And as we go further and further, we're going to be advancing this thing by sample duration. Maybe because of this thing, I want to call it delta time, right? So this is going to be delta time. This is going to be delta time. I also need to know the frequency of this thing that I'm going to be playing. Frequency, sound frequency, and it's going to be the classical 440, right? So it's going to be A-tone, right? So this is the A-tone. So let's go ahead and fill it up finally. Right, I'm going to be iterating through. Well, I also want to enumerate this kind of stuff. So we're going to do like that. So this is the sample. This one is going to be samples, right? Samples. In samples, iterate. I'm not sure if I need to iterate. Maybe I do need to iterate. Iterate in mutable way, and also enumerate. Right, something like this. Enumerate. Iterate, enumerate. So, and in a sample, we're going to be using something like 2 pi, right? So this is the 2 pi multiplied by the frequency that you're playing, right? So how did I call that? Sound frequency, right? So this is going to be, oh my god, sound frequency. All right, I take this entire thing, and I also need to multiply that by the time, right? I also multiply by the time, and I take the sine of this entire thing. So after that, I update the time by delta time, and this is how I fill up the whole buffer. Right, let's try to now build the entire thing, right? So it doesn't really work because we don't have... so this one probably has to be as F. You know what? Frequency can be actually fractional. I don't see any reason for frequency not to be F32. If you know what I'm talking about. So there's no reason for it to be not F32. So it could be float. It is totally fine. It is in fact totally fine. Okay, so pi is not in the scope. We can try to bring it to the scope. Somewhere here, use std. I think it's f32 consts, right? F32 consts pi, if I'm not mistaken, right? So that's the way you do that. There we go, and now it compiles. Okay, cool. So, and after that, I need to write this entire thing into the buffer, right? I'm writing that into the buffer. Though I have to be super careful because, again, it may produce a very loud sound, and maybe to, you know, make it a little bit more safe, since we're programming in Rust, I need to multiply the whole volume by like quarter, right? Maybe I can even make it like 10, so it's not really harsh. So here I have to provide the sync, and now comes the data. Okay, this is the interesting part. So I can try to take samples as the slice, right? And if I remember correctly, slice has a very cool feature. You can take it as a pointer. Yeah, so we can take it as a pointer. I wonder if we can just do something like samples as PTR, there we go. And though it also accepts bytes, this one is interesting. So it's not in elements, it's in bytes. It's in bytes, so that means we'll have to compute the bytes. So this is going to be 4 multiplied by the sample's length, right? So this is going to be sample length, and then we can also provide the pointer to the error, right? So, and this entire thing will either fail or not. I'm not 100% sure, but yeah. I'm not sure if I want to handle any errors in here. So that should be it, unless we'll have to cast the pointer to a different type, if you know what I'm talking about. So let's actually save this entire thing, and apparently we do need to local variable with the similar, it's a sample C. So C void F32. Okay, so what's the easiest way to cast the pointer? We'll try to maybe assume it's essentially as const C void, but maybe there is a better way to do that. Yeah, expected usize bound U64. So usize is not the same as U64, if I understand correctly, right? So it's not the alias. They're not aliases. It's literally a primitive type. Okay. Oh yeah, it's literally primitive type that is not aliased to anything else. Okay. That is totally fine. I can probably live with that. And maybe I can convert it to as U64. So is it working? Okay, so it seems to be fine. So in the original application in here, right, so we write everything into this thing, and we do the drain at the end, but the drain is needed to just ensure that we outputted everything. So we don't really have to do that if we just want to test how the thing works. Right, so, and I think we're kind of ready to do that. So prepare your ears, because I'm about to actually run this application. Right, so if I run it like that. Okay, so we should hear the 440 Hertz tone, sine wave tone, hopefully. So I'm gonna prepare a Control-C. Does anyone have any questions about what just happened on the screen? So we did a couple of things that were not about the style and naming, tabs versus spaces, camel case, snake case. We did the actual work. Does anyone have any questions about that? Not accepting any questions about style, some other bullshit that has nothing to do with integrating our applications with Pulse Audio. Does anyone have any questions about that, about the important part of the application? Not the crap that majority of people care about. So, because you see, that crap didn't help us to produce the sound wave. So my keyboard has died apparently. So sad. So the mouse still works though. This is literally what it feels like, right? So you're trying to tell me, guys, here's the important thing. All of that shit is not important. They don't listen. They're just like children screaming around and running. So I didn't even know. I didn't even know how to like I'm literally showing people that this shit is not important. They're not listening because no. You have to align it a particular way. You have to use this package manager. Yeah, you have to do. None of that is important. Listen, people. I'm just showing you that it's not important. You can do all of that without it. It's not the point. Does anyone have any questions about what just happened on the screen, right? So okay, so this is a sine wave. We can try different tones now. And it's actually pretty cool. Now I have a tool in my toolbox to generate sounds directly using Sound API, integrating with Pulse Audio, at least on Linux, and it's going to work at least on Linux, which is good. Okay, so I can multiply this thing by 2, and I suppose it's going to be twice as much. Okay. Do you have to completely fill 1K buffer before a sound plays? I think so, because well, yeah, this entire API is synchronous as far as I know, right? So you give it this entire thing, and if I understand correctly, this entire thing blocks until it finishes, and then, well, no, otherwise you wouldn't have a drain. This one is really interesting. Maybe it actually queues, but yeah, you have to fill 1K of data, and is that a problem? You think so? I'm not really don't really understand what's your concern. I guess the answer is yes. You have to fill 1K buffer before playing the sound. It is true, but what's the concern? Is there any concern with that? So that's why I'm actually not really sure what you're trying to say, or yeah. Is there any particular concern about filling 1K buffer before actually playing the sound? Oh, you don't have any concern. Okay, so maybe it felt like maybe you had concern with the latency, right? So you have a little bit of latency before playing the sound because you need to fill up the buffer or something like that. But I didn't see any concern in here because 1K bytes literally fits into L1 cache, I think, of the processor, right? Does it not? I think it fits into the like L1 cache, which is like the fastest memory that you can ever imagine. It doesn't it? I might be wrong actually, I'm not a hardware person, but I think filling up 1K for a computer, for a modern CPU is just like literally nothing. L1 30, oh okay, so it's even bigger. Okay. So does anyone have any other on-topic questions about what just happened on the screen? So what do you use to connect to Pulse Audio? Is it a channel loopback module constructed or something? Is it automatically destroyed when the program closes? I use something called Pulse Audio Simple, right? And it's a PA Simple New. I'm not sure if it's automatically destroyed, but if I understand correctly, Pulse Audio is like a similar to X11, right? Wait a second. I would assume that it cleans all of the resources after I quit it. So we can actually try to do something in here. So I'm gonna try to play the thing. And here's this stuff. And then I do Control-C and it automatically destroyed. I didn't really destroy this thing explicitly. So, but Pulse Audio now knows that this thing does not exist anymore. So I suppose it's like X11, the lifetime of the resources is tied to the lifetime of the connection. So since the application has quit, the connection to whatever is IPC was closed, so all of the resources will automatically deinitialize. But that's my assumption, it's just a hypothesis. At least this is how I would expect Pulse Audio to work. At least this is how X11 works, and it does make sense. So I might be wrong actually. I started to use Pulse Audio like today, so I never used it before today. Basically, I ported this application, this small application to Rust. That's basically what I did. So I'm not doing anything that is not done in here. All right, so let's continue. So we have that, and what I'm thinking is that maybe we need to merge like both of these applications in here. I'm gonna sneak by the way. Okay. So this entire code is a little bit messy. I do realize that, but I do plan to actually clean it up after I finished it. Right. So basically, I'm just throwing everything into the file until it works and produces something. Right, and then I'll think about cleaning it up, maybe also, I'm not going to even say anything about the naming convention, but yeah, you get the point. So we have that. All right, so here we are initializing the stream stuff. So created playback, and here is the samples, and here is the interesting stuff, right? So I want to integrate this entire stuff with the visual application that we developed yesterday, right? With the visual application, and I wonder how exactly we're going to be doing all of that. So, so here's the loop. And in here, essentially, what we do, we handle the events, then we are rendering the frame, swapping the buffers and whatnot. And I think somewhere in between, we can try to play the sound, right? I'm not sure what would be the best way to do this kind of stuff, if you know what I'm talking about. But I guess it makes sense to play it between the things. Furthermore, I actually disabled vsync for now, right? So vsync is completely turned off. So I think it's not gonna block anywhere in here, hopefully. So now we should be able to see the visualization and the sound simultaneously, hopefully. It's not the best way to do that, but it's a way that kind of works for now. Okay, so let me recompile the entire thing. And we can't hear anything, which is rather strange, right? Because it kind of blocked for whatever reason. And where exactly did it block? I'm not kind of sure. Okay, so I'm gonna disable PA simple, right? Right, I'm disabling this entire thing, and I'm gonna try to recompile it one more time, right? And oh yeah, the graphics stuff completely broke. So I don't know what is blocking here. What is blocking? I don't see what's blocking here. Oh, I see. So yeah, okay. So here is an interesting thing. Here is the interesting effect of a lot of warnings in Rust, right? So you show so many useless warnings to the point that the user of your language doesn't care about warnings anymore. And even if you provide a useful warning, nobody gives a shit anymore. So, right, so nice way to make warnings useless. It's like no warnings at all. I don't even know what to say. Okay, so here is the visual part of the application, right? Here's the visual part of the application, and here is the audio part of the application. The frequency that you need to update the sine wave is the same that you need to update the screen? Probably not. I'm actually, frequency at which I update the sine wave is actually smaller. You see, I actually update sound 1024 times per frame, if that makes any sense. I can extend this buffer actually. But I can, yeah, probably I'll need to synchronize it with the frame rate. Right now, synchronization with the frames is not really needed, if you know what I'm talking about. Like, but then as we start integrating with the simulation, maybe we'll start actually thinking about synchronizing the sound. Right now, it is not needed. I'm just trying to make something work. Okay, so there we go. Okay. That seems to be working. Where is the frequency? So it was 4. I don't want to multiply by 2. Okay. Alright, so we're playing the sound and the visual part simultaneously. And my keyboard has died yet again. I don't know. I don't fucking know why. Does anyone have any questions about not warnings or some other useless shit? Okay. So does anyone have any questions about nuclear plant? You know, not the bike shit. All right. So what do we have in here? So I suppose I'm gonna be just compiling this entire thing. Oh, this is so exhaustive. Holy shit. Okay. Integrate preview with the pulse audio. And I'm gonna push that right as the repo. For anyone who might be giving a shit about what I'm doing right now, here's the source code, just in case. So, all right. The next thing is going to be, yeah, we have all of the necessary parts, essentially, almost. I'm not 100% sure if we have all of the necessary parts, because the problem with the simulation, right? The problem with the simulation that we're playing in here, so let's actually take a look at the simulation one more time. Right. I don't know what the fuck is going on in here, but it's not supposed to be like that. Right. So the thing about the simulation is that it generates the frames pixel by pixel, right? And this is not precisely how the OpenGL renderer works, right? So with the OpenGL renderer, you have to go through this entire pipeline and stuff like that. You cannot just give it the pixels and it will display them. You can, but you have to put extra work into doing so, right? So what we'll have to probably do, we'll have to generate a texture, right? So we have to create OpenGL texture. We'll have to render the frame. Then we have to put that frame into the texture and display that texture using OpenGL and continuously update that texture. So that's probably what we'll have to do, which is not particularly a fast way of doing that, but it's the way we can apply right now, because that's how our renderer works, right? So it is crappy, but it's okay for now because more, like, better implementation requires more work, right? You know what I'm talking about? So it would be better because if you take a look at the renderer that we have in here, we have a bunch of rectangles. It would be nice to actually have a specialized renderer which collects all of the rectangles that you want to render in a vertex buffer object, right, and then sends it to the GPU, and then on the shader level we would unpack all of that, properly render the vertices of the rectangles, and then properly color the rectangles in a fragment shader. So it's a completely different way of rendering things that we do right now, right? Make sense? So, and that would be the best way to do that, but since our renderer works differently, it is better to just do that through the texture. Right, it would be better to do that through a texture. Right. So I need to think what's going to be the next step, because I'm kind of done with the sound, with integration to Pulse Audio for now. I just have to move on to a texture, and this is like a completely different topic. And I'm thinking, do I want to split this into 2 videos or something? Because yeah, I'm kind of done with integrating with Pulse Audio, so maybe it could be a separate video. We'll see. So for now, we'll basically do the software rendering and only use OpenGL to display stuff. Yeah, pretty much. I don't even use OpenGL to display stuff. That's the point here. So to use OpenGL to display stuff, we still need to put some effort into doing that. So far, we managed to create OpenGL window. Welcome to the modern computer graphics, by the way. We spent the whole day just creating OpenGL window. So we can't even use it to display things yet. So we'll have to spend a separate effort connecting these 2 things together. And then maybe, just maybe, we'll see things moving on the screen that is similar to what we have in here, right? Right now, what we see on the screen when we do a preview is not even close to that thing, right? So, but you need to spend some additional time and effort. All right, so I want to make a small break, right? I need to make a small break. And after the break, maybe we'll do something. I don't know. Yeah, after the break, we're gonna try to connect, the renderer with the texture. So, all right. So let's try to integrate with the texture rendering, right? So how are we going to be doing all of that? Well, I suppose we'll have to first create the simulation context, right? So here's the simulation context, and what we have to do in here, we just need to create this thing providing the width and height of the simulation, width and height of the rectangle within which all of these things are going to be bouncing like around and stuff like that. So what I need to do is probably so I'm gonna put it in here. Maybe I'm gonna use self. I think it's actually located in super. Right, so yeah, so in the main we basically put all of these modules as submodules. So rendering and preview and the simulation are located on the same level, right? So because preview and renderer are going to be reusing the simulation, to access this entire thing we'll have to do something like this: simulation super, and we're going to import everything. And as far as I know, in the simulation itself, only the state is visible outside, right? Only the state is visible outside. So let's create the state. So this is going to be state, and it's going to be mutable, state new. And the question is, do we have width and height? We do have width and height. So let's actually provide it in here. So it's going to be width as f32, height as f32. There we go. So, and that creates a new state that we can probably use. We don't know yet, but we can probably use that. So the next thing we need to do, we need to render the state, right? So we usually render it into a canvas, right? So all of that is rendered into a canvas. So for that, we'll have to allocate a memory for the canvas, right? So we can do canvas, canvas vector. So we're gonna fill everything with 0, and it's gonna be width multiplied by height. Width multiplied by height. So that's the canvas. So, and for now, I'm not going to be running any simulation. I'm not going to be stepping simulation. What I want to do right now, I just want to render the current frame of the simulation. Right, so I'm going to be doing state. Then I'm going to say, please render yourself, go render yourself into this canvas. And the canvas stride is actually width, right? So this entire thing will render the state into this canvas. And now what I want to try to do, I want to try to make a texture out of that canvas, right? So I don't remember how to create textures in OpenGL, to be fair. So we'll have to find out. So if I try to recompile the entire thing, everything seems to be recompiling, right? And if I run, there we go, seems to be working. So I hope it's not too loud. Please tell me if this thing too loud. As far as I can tell in OBS, it is not that loud. It doesn't even reach the yellow area. Right, so it's all okay. Thank you so much, guys. Really appreciate it. Okay, so yeah, so we rendered that, and let's go to the OpenGL. As far as I know, you need to first generate a texture, right? So you need to generate a texture. GL extension, GL gen texture, textures. And it's extension, so it's with ext, so which actually leads me to believe that maybe it's not an extension, so you have to do it like that. Okay, so let's actually bring this function into the OpenGL bindings. Right, so we're gonna have it somewhere here. Generate a texture, so this is gonna be n. And then the texture itself is going to be a mutable pointer to this entire thing. So let's go ahead and do that. So here we do initialization, so VAO, then we're doing shaders, and I'm not sure, maybe I'm gonna actually initialize the texture after I've done the shaders, but I'm not 100% sure, maybe before. Cannot decide. I don't know why I cannot decide. I think there's something wrong with me. So this is gonna be mute frame texture, GLUint is 0. So this is going to be 1, and then I'm going to take the pointer to frame texture. There we go. So we generated the texture. So after that, I need to bind the texture, right? So I need to bind it, saying that that's the current texture. That's the current texture. So let's actually put it in here. Bind. Right, something like this. Something like this. GL gen texture. The target. Oh, the target is rather interesting. So I think it's something like GL texture 2D. Yeah, that's the thing you need to have in here, right? It's a GL texture 2D. So this is gonna be const GL in num. It's gonna be equal to that, and there we go. GL bind texture. There we go. GL texture 2D, and then I provide the frame texture. So I don't quite remember what's going to be the next step. Do you have to... I suppose you have to provide some parameters. You also have to initialize the data. So I'm gonna actually go to docs.gl just to get reminded of how to work with textures. GL gen texture, because they usually have some sort of like a piece of code down below that you can like refer to for the whole thing. Okay, so we generate, and then we have to provide some parameters in here. They really matter. I'm not quite sure. So this is a linear interpolation. Some other stuff. Let's actually don't use any interpolation, at least for now. Alright, so for that one I'm going to be using nearest, right? So it's going to be very pixelated. To be fair, in our case it is already pixelated because our render doesn't do any interpolation anyway, so it doesn't really matter. So what we have in here, what we need in here is this constants, right? Alright, so mag and min. So const JL. So let's define this thing in here. So, and as far as I can tell, so this thing has to be GLUint, right? Maybe, maybe it's actually enumeration, more of a. It's more of an enumeration of our nation. So does it compile? Okay, so I also didn't provide this function as well. So let's actually go and provide it. So so that's what we're gonna have in here. Target. Anything else? Nearest. So const nearest, I would assume that it's also glnum. Though in C the specific type is not visible anyway, so it doesn't really matter that much. Okay, expected I32. Oh, okay. So this thing expects I32. So does that mean GL text param GLint? So that means this thing has to be GLint. Sure. Does it work? Seems to be working. Seems to be working. Okay. So there's that, and then we have to provide the data. Okay, so now we come to the point where we need the GL texture image 2D. GL texture image 2d. This one is going to be rather hard because it has a lot of parameters, but I think we're not afraid of hard problems. Right, that's kind of the point. That's kind of the point. A lot of people are afraid of the hard problems and they're trying to switch the topic and talk about, for instance, different like namings or like types versus spaces, because that kind of topics give them the comfort, so they have an opportunity not to think about actually hard problems. But we are not afraid of thinking about actually hard problems and trying to solve actually hard problems. So that's what we're doing on this channel. Right, so let's go ahead and do that. So this is the type, so I think we'll have to do something like this. So in the pixels is going to be literally a void, which is rather interesting. Do we have a thing for the void? GL void. Okay. Type GL void. Okay, so that's the function. All right. Let's see. Target is going to be GL texture 2D. The level, as far as I know, the level is let's actually go to GL texture 2D. Level is basically a specific meep map level, right? So since we don't really care about meep maps or any of this shit, we're gonna say that it's 0. Internal format specifies the number of color components in the texture might be 1, 2, 3, or 4. So I think I'm gonna just literally say 4, right? So we have 4 of them. Width and height, we do know width and height, right? So this is gonna be something like this. The border could be 0. We don't care about the border. The format, all right. So the format, I guess we can say GLRGBA because it's like 4 components or something. Yeah. GLRGBA. So we're gonna get the components, the format completely incorrect because I'm actually rendering everything in a format that is convenient for me, right? So and I think the format because of that is something like 0xAA RRGGBB. So, and I wonder, do I have to, I can always like fix that myself. I can always like change it myself. But maybe there is a way to actually tell OpenGL, interpret this thing like that. Right, so I think, I don't know. For now, I'm gonna just say that the format is GLRGBA, and it's probably gonna be incorrect, and that is fine. It is totally fine to write first like incorrect approximation and then fix it. That's kind of the point. Specify the data type of the pixel data. The following symbolic, I can never remember. I think it's unsigned byte. Specifies the data type of the pixel data. And what is the pixel data? I suppose I'll have to put unsigned byte. We'll see how it goes. And the pixels is basically the canvas. Right, so this is the canvas. And I need to take it as a pointer, and then I will have to cast it to GL void. So that's how I can fill up this entire texture, hopefully. And it does not compile because, oh yeah, this entire thing has to be I32 as, where is this? GL int as GL int as GL int. Oh, right, so GLRGBA. Okay, so let's actually define GLRGBA. Right, the GLRGBA const, and what is it supposed to be? GLRGBA. So it's supposed to be GL in num, right? So GLRGBA, that's the value of this entire thing. Okay, do we have anything else? Unsigned byte. Where is unsigned byte? Here it is. Let me bring it in here. Const GL, right? Const, and this one I don't really know. I think it's also GL in num. And let's put it in here. Okay, do we have anything else? And it seems to be compiling. How about that? How about that? But we won't be able to see anything. If I just run this entire thing right now, it's the same as it was before. It's absolutely the same. So the reason is because we're not like using this texture at all. Right, so I can now go to the preview. Right, and in here, so I suppose in this thing we don't have to do anything special. Right, but in here we have to set up uniform. And I think it's a sampler 2D. Right, and this is going to be the frame. This is our frame. So it's actually tied to the texture units, and the default texture unit is 0, and by default when you create the texture is going to be tied to the texture unit 0. So I don't really have to do anything in here. By default it will work, and let's see if it's going to do anything particularly special. So if I compile it, okay, so everything seems to be working. Now, instead of generating these stupid colors, right, what I need to do, I might as well actually comment out the entire thing. Right, so this is going to be something like color. So GLSL texture. GLSL texture. That's what I need to do in here. So it provides the sampler and a particular vector. So I suppose I can just do texture frame UV, and that will just use the texture right away. Hopefully, we'll see. I'm not sure. So here's the thing. What are we doing? Just to recap, right, before we actually try to run it. We create the simulation state. We create a big enough canvas buffer to render that state in there, and we're just rendering the first frame of the simulation. We don't advance the simulation, we don't do anything with the simulation. We just render that frame in there. Then we initialize OpenGL sound and stuff like that, and what we did, what we added to the OpenGL initialization, we created OpenGL texture with the same size as the canvas into which we render the state. Once we did that, we took all of the pixels of the canvas and we uploaded it to OpenGL texture. Then we updated the shader to actually use that texture, which contains the frame of the simulation, and just colors the quad with that frame. Right, so, and let's see if it's gonna work right away. And it doesn't work, so that's pretty cool. So maybe the time has come to bust out the render doc. Right, because who knows what the fuck has happened there. So maybe the texture was not uploaded properly. But maybe another thing we can do, we can enable debug output for the OpenGL. So if there are any problems, it will probably log something in there. But I don't know, let's try render doc first. So I already actually, yeah, I remember that I actually moved render doc to here, so let's actually copy it in here and tar fvx render doc. There we go. Okay, render doc. Q render. Oh boy, I don't really want to run it in a sync manner, but I'm afraid it can log a shit ton of stuff. I really hate when like these applications you want to run in the background, but they start logging like shitting right into your console. It's just like so unpleasant. Anyway, so why is it so slow? Okay, so do we have a command line parameters? Okay, so I can provide the preview, and let's actually try to launch. And I want to capture. Oh, I just remembered it cannot capture. Core profile not explicitly requested, compatibility profile is not supported. Okay, so, oh, we also need to enable the core profile explicitly. So render doc is not gonna work that easily. Render doc is not gonna work that easily. Oh. Truly sad. So it could be also because of some alpha shit, you know? So I have an idea. What if I go into the simulation? So, and here's the fill gay rectangle, okay, right? So it's a rainbowish rectangle. So what if I fill this entire thing not with this kind of color, but rather with FF, 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 FF. So basically all of the components are going to be 255, right? So, and then I'm going to try to recompile the entire thing, right? And just run this stuff. So kill the render doc, it's useless. And let's preview. Yeah, it still doesn't show anything. It still doesn't show anything. But, okay, so we also need to eliminate the case that maybe the first frame doesn't contain anything. That also could be the case. But I really, really doubt that. I really, really doubt that. So what we can try to do, we can try to dump that rendered frame as a ppm image. Speaking of using ppm for debugging purposes, this is literally the case. Right, you have some sort of a frame and you need to see if is there anything there. So, and since our application is not allowed to use any third-party dependencies, we can just dump it as a ppm image, right? So save pixels as ppm. So we're going to provide the pixels, right? So it's going to be like a reference to i32, and we're going to have a stride in here. It's going to be usize, and then we'll have to provide the file path, I suppose. So this is going to be file path, and this is going to be just a string or something. So now I need to open a file, rather create the file, right? So it's going to be file path. Maybe I'm going to actually return something like IO result, like this. And let's do something like sync, right? All right, so write ln mutable sync p6 p6, then width height 255, width height. So width is effectively stride, but height is pixels len divided by width. So we have that. So this is the width and height. We don't really need it as much, so I might as well actually do something like this, right? Because we don't really need these parameters. As soon as we like save them, as soon as we save them, we don't really need them. So after that, I'm going to be iterating the pixels, right? I'm going to be iterating the pixels, and I need to save this entire thing in there, right? So I guess I need to extract the bytes, right? So this is going to be R pixel 8 multiplied by 2 G B sync right RGB. So after that, I suppose I want to explicitly say that this thing as U8. Okay, so, and then I'm gonna say okay. So IO rest, so we'll probably have to import all of these things. So it's gonna be std IO. Right, do we need anything else in here? So file, as far as I know, file is located in something like this. Right. So pixel, okay, so this has to be like that. There we go. What else do we have in here? So there's no errors, only warnings, right? So now, right, method not found mutable sync. Okay, so it has to be something like right. There we go. Oh my god. So let's go ahead and do that. Cannot borrow as mutable because it's not mutable yet. Do we have anything else? Okay, so it seems to be working. All right, so we have a function that can dump the thing, the frame into the file system, right? So let me see. So save pixels as ppm. Right, so save pixels as ppm. Right, so the file path, and this is going to be the frame ppm. Canvas, it has to be a mutable canvas, of course, and the stride is going to be width. Right, the stride is going to be width. What else do we have in here? All right, so and if I try to run this entire thing, it did the thing, but did it also create the frame? Okay, so it created frame. Let's actually open it. It does exist in there. Okay, so the texture, the frame does in fact contain some stuff, which makes sense. But it doesn't display anything, right? It doesn't really display anything, but we illuminated that case, right? We definitely illuminated that case, which is nice. All right. We definitely eliminated that. So that means the problem is with the texture, right? So with the texture itself. GL texture. Okay, let me think. So maybe I'm gonna take a look at the piece of code they provide in here one more time, right? So so RGBA, RGBA. So in both of the cases they use RGBA. Maybe I'm gonna also put RGBA in here. I don't know. GL RGBA. So 0 texture width, texture height. The border is 0, RGBA and sign in, and then we provide the data, and everything's okay. So I don't see any mistakes in here per se. Everything looks okay to me, at least. So maybe we have to do that after we, like, it's quite unlikely, but maybe you have to do that after you allocated the program or something. I actually really doubt that, but RGBA expected. Okay, so I can try to do as I32. Oh, right. So, oh, okay, it worked. Interesting. Interesting. Well, also, it's actually upside down, as you can see. It is actually upside down. Is it really because I'm doing that before the program? Because I'm relying on some default behavior, which is probably a bad idea to do, right? So, right. Is that because... What was the cause of the problem? That's really strange. Oh, okay. So where is that? One, two, three, four. One of the following constant. Uh-huh. Okay, that means I don't have to use one. Okay, sure. So that was the problem. I don't know. Maybe I'm just not understanding something, but it's kind of strange. But you see, it works now. So so this is the first frame, right? So this is just the first frame. Now it's upside down, so we probably want to actually invert the coordinates. We can do that in the shader itself, right? So we can do something like vec2 x uv y, and we're just basically inverting the y coordinates, so it's going to be upside down now. Now it's exactly in the place where it's supposed to be, right? So everything's okay. Let's try to color it with a rainbow, right? As I already said, we are not interpreting the format the way... So OpenGL may not interpret the format the way we interpreted it, right? So we'll have to probably adjust something, but I'm not really sure. Okay, so gayrect, where's the gayrect? I don't remember. So I think it's a simulation. I already was there. Okay, so let's go back to the rainbowish stuff and see how it's gonna work now. Let's see how it's gonna work now. Okay, so you may say that maybe that's it. Maybe that is working, but it's not really working exactly as you want. Right. It's not gonna work exactly as you want. So I want to disable the sound because it's kind of annoying to listen to that sound. It's kind of annoying to listen to that sound, so maybe no, we're not going to be doing that. I'm not going to be doing that. So what I want you to do, chat. So we're saving that frame. Okay, so there's no sound anymore. And if I take a look at this thing, you see? You see the problem? So it's interpreting them incorrectly, right? So, but since it's a rainbowish, it doesn't really matter. But I think I do care. I think I do care about how it interprets this entire thing. So, can I specifically say the format? Is there any way for me to tell the format? So there is luminance. Well, we can reinterpret the format on the shader, if you know what I'm talking about. Right, we can reinterpret it on a shader. So let's actually go to the shader and do the preview. So we're gonna have the pixel in here, right? So it's gonna be pixel, and this is gonna be vec4, like this. So this is the pixel. So the format is something like AA, RR, GG, BB, and RGB, because of the little engine, is going to be right. It's going to be RR, GG, BB, AA. But since it's a little endian, the first one is going to be R. So that means the first one... So the first one is alpha. That means I have to do Y, ZW, YZW, vec4. And I don't really care about alpha, so I might as well try to do something like this. Right. I think that's the way to do that. What do you guys think? Right. Let's see if it's gonna actually produce something reasonable. And it crashed because why? So the shader didn't compile properly because I forgot the semicolon. All right. So let's try to recompile one more time. And a boom. Okay. So it's completely wrong. Okay. So maybe it's WZ. It's completely wrong. So RGBA. Oh shit. Okay, so endian is actually screws up with my brain. So yeah, I see. So that means RGBA is AA, BB, GG, RR. Right. So this is RGBA, and essentially, this is the first one. So X is gonna be blue. X is gonna be blue. Y is going to be green. Pixel Y. And Z is gonna be red. So it's gonna be pixel Z. So Zix. I think it's a Zix. I think it is in fact Zix. Yes, it is. Yeah, there we go. So no, that's pretty cool. So the next thing we want to do, actually, we want to try to like actively simulate the entire thing. But to actively simulate the entire thing, we need to update the texture. As far as I know, you update the texture via the texture sub image 2D, right? So that's what you do, sub image 2D. So we need that function in here. So specify to do texture sub image, a portion of specified texture image onto each graphical primitive. To enable or disable two-dimensional texturing, or whatever. It's kind of strange. Texture 2D. Texture 2D. All right, so let's actually bring this entire thing and see if we can do something about that. So that's a pretty huge goddamn signature, not gonna lie. Okay. So where is the JL? All right. So this is gonna be the target. And this is gonna be the level. So it's basically the same as GeoTexture image 2D, right? It's basically the same, but it allows you to update it. So dumb. Okay. So this is the format, and we also need to have the type. So, and this is the data, right? So this is the data. So the thing is, for offset and some other stuff, we're gonna just keep using like 0, 0 and width and height, so it's not really needed per se. Right, so this is gonna be the data, and there we go. Oh boy. Okay, so I need to do that on each frame essentially, but I also need to synchronize that to like 60 FPS or something. So we'll see how we can do all of that. One of the things I can do, I can basically for now do swap interval, right? So where is the swap interval? And I basically turn on VSync. And that will ensure that it's 60 FPS, and I can just do that at 60 FPS. Right, so let me see, state update. When I update the state, by the way, simulation update the state, I provide the delta time, right? So that's what we're providing here. State. And the delta time is going to be essentially 1 over 60, right, over 60. So then we do state render, right, so we do state render. Do I need to clean the canvas? I think I need to clean it just in case. Canvas, fill with 0, essentially, right, so this is going to be... Do I really fill it with 0, or do I fill it with the background? I don't quite remember. I think... in the rendering, I do canvas fill with the background, and the background is this thing. I'll have to actually bring these parameters to both of these places, but I'll do that a little bit later at some point. So we render this entire thing, so we need to do GeoTexture sub image, right? GeoTexture sub image. Right, and there we go. So this is going to be the target, and GL texture 2D level is going to be 0. We're not going to have any offsets. Then we need to have width and then height. The format, I forgot what's going to be the format. Do I have to use the format? I'm going to use GLRGB. Doesn't really matter. The type, what's the type? I think it's an unsigned byte, right? GL unsigned byte, and then I have to provide the pixels. So it's going to be canvas as ptr as const gl void. That's what we're going to have in here, and this thing will create this shit for us. Hopefully, we'll see. So let me see if it's going to be doing all of that. Okay. It's actually sustainable at 60 FPS, I think. Yeah, it's actually sustainable, right? It's very cool. Does anyone have any questions about what's just happened on the screen? Does anyone have any questions about what we just did? Like, pretty cool shit just happened. Does anyone have any questions about that cool shit that just happened? Yeah, I created the texture on the CPU, right? I literally did exactly what I said. I created the texture on the CPU and I passed it to the GPU. And the way I passed it is through the GL subtexture image, right? So it allows me to constantly update the currently bound texture. So, and yeah, as you can see, I just basically rendered and I say like get these bytes and update this entire thing. And surprisingly, it's fast, it's sustainable at 60 FPS. Well, I mean, it looks smooth as fuck. I didn't expect it to be this smooth, but it works. So that's pretty cool. That is fucking extremely smooth. Not gonna fucking lie. So yeah, does anyone have any other questions about the cool shit that we just did? So we had a renderer. So yeah, we have a simulation module, and the simulation module is completely platform independent. Seriously, it's completely platform independent. It doesn't care what operating system do you use, what API, what graphics API do you use, what sound API do you use. This entire module doesn't care. What it does, it exposes 3 methods: update, sound, render. Update accepts delta time, basically the amount of time that has passed since the previous update, so you update in the simulation. Then it accepts a render method that accepts array of pixels, and the state renders itself pixel by pixel into that array, right? So it renders itself pixel by pixel. Then it accepts a sound, like it exposes sound method that accepts a buffer of samples, and it renders the sound that it needs to play into that buffer. So that way you can take that module and integrate it into any platform you want, right? So does anyone have any questions about this cool shit that we just did? So here's another interesting thing. You can render this entire video, this entire simulation into a video file by doing render. Right. So it will basically take all of the output of the simulation and dump them into raw video files, right? It dumps them into raw video files and you can view them separately. I should have actually done slightly differently. Just a second. I should have actually called this script, right? Because then it will call ffmpeg to merge both of the files together, right? So you see, you can hook it up anywhere. So right now I hook it up into the renderer that saves it into a file, right? Into a video file and audio file, and then merges them together. So we'll need to wait a little bit until ffmpeg actually does all of that. Right. So if I do mplayer mp4, and that's the final result. Everything you see and hear right now was generated by these 3 methods. So we update the simulation to the next frame, we render the frame, the sequence of these frames that you can see, right? We render them pixel by pixel, and we generate a sound sample by sample, 48,000 samples per second, actually drawing the sound waves. That's what we're doing here. And then what we did recently, we actually ported the entire simulation into OpenGL plus Pulse Audio API. We haven't integrated it with Pulse Audio API yet, but we integrated the rendering with the Pulse Audio API. So now we can do something like preview. And this entire thing now is rendered in real time into OpenGL texture. You see, we're using the same code to generate the video and to generate, to actually play the simulation in real time with OpenGL texture. Does anyone have any questions about this cool shit that we just managed to pull off? What's the simulation simulating? I don't think it's simulating anything particular, but it's just like bouncing things around, just like trying to get something cool. Right. So we hooked up the renderer into OpenGL texture. Now let's try to hook it up into the Pulse Audio, right? So let's also do the sound updates and whatnot. So because I want to see how it will play out in like with the sound. So you play in the sound and it renders a sound wave from it. How to say that? I'm generating the sound wave. That's what I'm doing. Not just playing the sound, I'm generating the sound wave completely from scratch. I don't know how to explain that. It's just like, have you worked with graphics API, with the sound APIs? So with the sound APIs, you give them a buffer of samples, and sample is basically like a pixel of sound, if you know what I'm talking about, right? Do you know what is a sample in terms of a sound API? Okay, what is a sound, first of all? What is a sound? A sound is like a wave, right? So here is the wave, and basically sample is a specific value at any point of time of this wave, right? Like this, right? So this is the sample. It's like a pixel of sound. So, and we're generating sound by generating the sequence of these samples. That's what we're doing, one by one. Let's generate it. Let's integrate with Pulse Audio. Okay. So I think I'm gonna take the buffer from the preview. Actually, render. So yeah, we have to do it like that. Right. So this is gonna be the. Where is the canvas? Where is the canvas? Okay, so this is the sound, and as we play the sound, yeah, we're gonna be doing that in a similar fashion, I think. We're gonna be doing that in a very similar fashion, so we're gonna do that, and so instead of this stuff, we're gonna just basically ask the simulation, right? Please fill all of that stuff in here. Oh yeah, so we take the sound buffer, then we give that sound buffer to this state, and then I can just use samples like sound, sound. Theoretically, that should be it, if I'm not mistaken. So in a render, how do we do things? We first render the video. Okay, so let's actually do it like this. So we fill the canvas with 0. We fill the canvas with 0. Right. So here it is. So we render this entire thing and we upload it to the texture. All right. Then we fill the sound buffer and we play the sound. Then we update the simulation. And after that, we're effectively, yeah, so we're just displaying this entire thing. So it kind of resembles the original structure in here, right? So if I try to recompile this entire thing, let's see how many errors we'll have. So the delta time is effectively, let's actually put the delta time somewhere here. Maybe I'm gonna actually steal this kind of stuff from here. So I can probably steal all of that stuff from here. Yeah, so this is more of a related to the rendering, and here this is more of a global thing. Right, this is more of a global thing. Sound sample rate. So we already have a sound sample rate, but we don't need that stuff. Okay. So do we have a width? Okay, so it will tell me if there's something wrong, of course. Previously defined. So where was it defined? 2027. Like this. Let's remove that. Anything else? Sample rate. Do we have anything else? Sample rate. Is that it? Okay, I think we integrated the sound, the sound with the pulse audio. So get ready. So because it might turn out very loud, right? Because I don't know if I introduced any bugs into the sound system. So if you have headphones with like a loud sound, take them off just in case as I run this application, and let's see if it actually produces a sound. Okay, it does produce the sound. There are some bugs, but it does in fact produce the sound that is, you know, what we hear in the original video. So it starts to clip a lot, if you know what I'm talking about. But holy shit, it works! We have the same simulation core that you can hook up into like a file renderer and real-time renderer. I'm curious how synchronization works. We don't really synchronize anything right now. Specific sample rate for the sound wave, which is different from the image update rate. Yes, it is different. We're not doing anything particularly special to synchronize anything. I'm just allocating the buffer is equal to the delta time of the frame. So, and I'm filling up that buffer specifically. So it of course, yeah, so there's nothing specific in the way it's implemented. It's just the conceptually, this proof of concept fucking works, right? So the cross-platform engine, right? So the thing is completely cross-platform. It only exposes the way to update itself, the render itself pixel by pixel, and render its sound sample by sample, and you can hook it up into different sources. You can hook it up into the file saver or into real-time thing. It has bugs, it has rough edges, it doesn't handle synchronization, but proof of concept here, it fucking works. It's so fucking cool. Holy shit. It's the same like thing, and it just can do. I don't know how to, like, I feel like I'm the only person who's excited about this stuff, and maybe it's not even worth being excited about. So, and yeah, sure, there are some video audio bugs, but all of that can be basically smoothed out over like time as you do this thing. So yeah, and now as you can see, you don't have to wait like half of an hour to generate this entire thing. Can it render music not auto-generated? What do you mean by that? I will surrender the... We don't have to do that anymore. It's kind of interesting that... I don't even know. Is it overwhelmed by the entire thing? So I probably need to read more. Source audio from outside the app. You can source. Well, I mean, what do you mean? Can it render music not out? Well, I mean. I don't know how to explain. It's easy to implement. It's not implemented in our application. I mean, because it's not needed, because that's not the point of the application. But it's not that hard to implement because the music, file music, is just a file that contains sound waves, the same sound waves that we generate. Not the same, but it's the sound wave. And instead of generating them, you just send them from a file. But why would we do that? It's outside of the scope of the project. Okay, so I want to save a committal of that. Does anyone have any questions, any more questions about this thing? Maybe something. You can find the source code in here if you're interested, like in the chat. So you can find the source code in here if you're interested. So there also, you can go to the What's channel. We have a playlist of this entire project where we started it from scratch. And so there's this thing. Where's the other thing? I don't remember. So there was, yeah, 2mpeg4yuv. So this is how the project has been studied. This is basically the 5th episode, and you can watch how we developed this entire thing from scratch. So if anyone is interested in this thing, is anyone interested? Why am I doing that? Let's make a small break. All right, let's continue. So I wanted to try one thing. I wanted to actually bring down the amount of squares we have in here. Right, so I used to have, I think, like bounce method. So it was like split bounce, right? So split, actually, every time you hit the wall, it splits the rectangle in two, right? So, and I used to have like a bounce method, which basically does not do that, right? So, and it also accepts orientation at which it's gonna do this kind of stuff, right? So it's gonna be rectangle. So, and in here, I'm going to just take that stuff, right, so copy paste it in here, and I'm going to only return one of them, like the left one. There we go. Right, so, so I'm going to return that, and that's going to be the bounce, right? So I think I'm going to say allow that code, right, allow that code. And There we go, so it seems to be compiling. So now, every time I call a split, where do I call the split? Okay, so here I call the split. So instead of calling the split, I'm gonna be doing like a bounce, I suppose. Rect bounce of a particular orientation. Oh, and when I do the bounce, I do not decrease the size of the rectangle. That's quite important. I do increase this the node, but maybe I should not increase the node at all as well. Right, so let's not do that. So essentially what we're doing, we're just modifying one of those things, which means that I can actually do something like mutable self and save on the lines a little bit. Not that it matters, but it's just gonna be more readable, if you know what I'm talking about. So self, is there any way to modify structures in a like a more immutable way, if you know what I'm talking about, like in Haskell? Right, Rust struct modification. Is there any special syntax defining how to modify struct instance in a function? Struct update syntax. Yeah. So struct update syntax, because the functional programming languages like to have shit like that in an immutable manner. Okay. That's what I was talking about. Though I don't think it's gonna make it more concise, right? So what we could do in here, well, we could do dy equals self dy minus, right? And then something like self. Okay, so that's basically what I wanted to do in here. You see? So it basically creates a completely new structure, and this one is going to be for the X. Alright, let's take a look at the errors, and it's colons, whatever. Syntactical nonsense. Doesn't matter. Remove this comma. Okay. Oh, okay, so we should not trust this article then. Okay, so here we have that, and maybe rect area threshold. I have a feeling that maybe the pushing a new rectangle should actually perform this kind of check. I think that's where it has to be performed. Right, so we have new, we have update, and so maybe I need to introduce something like a new rect, if you know what I'm talking about. So what I want to have in here is basically a fn push rect, right? So, and it will accept mutable self and the rectangle that you want to push, a new rectangle, and it's going to perform that specific check in there, so you're not directly doing it, if you know what I'm talking about, right? So this is going to be that, so self rects len less than that, and then the rect area is that, and that means we're pushing this rect. So in here I don't have to do that anymore, so it's going to be self rect push rect left and then right, and that simplified this entire shit. Okay, but I might as well also comment out this thing, right? I'm commenting out this thing, and might as well self push rect. Can I do it like that? I think I should be able to do it like that, right? So rect bounce, and we push a new one in there. Okay. Okay, is it gonna work? Is it gonna work now? Compilation, where's the error? Immutable borrowed, blah blah blah, blah blah, borrow checker, blah 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 blah. So the one immutable occurs in here. Oh, you already borrowed this self. Oh, for fuck's sake. Okay. Absolutely correct code, by the way. It's just like, yeah. It's just Rust needs to be an annoying piece of shit, of course. For whatever reason. Okay. Are you happy now? Good. Oh shit, that was weird. Wait a second. Oh fuck. Did it break everything, by the way? I think everything is everything okay, by the way. Does anyone even watch me? It feels like nobody's watching me. Because I don't have any feedback from the chat at all. So I don't know if something happened. So I can see, okay. Was there anything weird? Alright. I don't know why is it doing that. That's so weird. Why is it doing that? It's actually stuck. But why is it stuck? Oh, I think so. Okay, it's a different bounce. So if it's a, well, it should work. You know, this is stupid. This is stupid. So self dy multiply by -1. Right. Dx. Integer, sure. Okay. What do we have in here? Why is it stuck? The fuck? Was it always I don't remember it being stuck. But it's all... Man... The fuck? Okay, so here's the rect. So... Bounced rect. Bounced rect. Well, I mean... I might as well push it right away. I don't really need to check the caps or anything, so I can just do it like that. Bounced rect. Right, so I don't need to check shit. It used to work, but it stopped. It used to work. What the fuck? The fuck? It used to work. I remember. So if I render the video, let's actually try to render this thing. Right. It used to work perfectly, so why did it stop working? So is there any discrepancy between the preview and the actual rendering? So that's the question. So let's see. Okay, so that means the bouncing is implemented incorrectly. So something is wrong with the orientation, I suppose. Oh, I remember. I think I kind of remember. I'm really tired. Okay, so what if I don't put the right one? I'm gonna not put the right one, right? So, and... well, it becomes smaller every time, but that's fine. Right, but I don't want it to become smaller. That's precisely what I'm doing, so... and that's what I wanted with the bounds, though, right? Ah! Is that what I needed to do? I don't remember. Like, why split works, but the bounds doesn't work? So, what's the difference between these two things? Why it doesn't work? It's the same shit. I do bounds, right? And essentially, what I'm returning on the left one, I'm not returning the right one. Why doesn't it work? What the fuck? Right, I'm just returning the left one, right, not the right one. And on top of returning the left one, I'm not modifying it. So that's one of the things I'm doing. That's the main difference in here, right? So why doesn't it work? So okay, again, on the left one, not the right one. So no modification in here, right? So no any of that shit. So on the left one, it's a little bit verbose, but that's kind of like otherwise it doesn't want to work for some reason. So in here, right? So we have a rect, and on top of that, I just do self rect. Right. Push rect bounce. Bounds, please, for a particular orientation. Right, so that should work. Why doesn't that work? Okay, so... useless shit. Okay. Bounds, duplicate definition. Yeah, so I'm gonna remove that thing in here. Right, so I'm removing that shit in here. Now it worked. What was the difference in here? Am I stupid? Okay, well at least it works. And now I wasted so much time and I still don't understand why the fuck it didn't work. So I probably made a very stupid mistake somewhere and I don't understand where I made a mistake. I still don't see it. I literally don't see the mistake, but okay, sure. Whatever. Because I'm tired. I'm really fucking tired right now. Okay. Why did it become lower? It became lower all of a sudden. What happened? What do you mean? Did you hear something? What did you hear? I heard that it became lower. What was that? What was that? Ah, yeah, sound. Because you all reacted like there was some ear rape or something. I don't understand. That was weird, but... Pitch dropped, yeah, so I don't know, it shouldn't drop. I don't know why it dropped. So yeah, we probably have a huge bug in our mixing. And this is a real-time preview, right? So you can preview this animation in real time, or you can render this entire thing into a final video. Right, and rendering into the final video does not require any OpenGL or anything like that. Right. So we're just generating thing, and that's it. So let's take a look at the final video. Yep. So it's generated by the same renderer, right? It's just outputted into the file. This is a very cool exercise in software architecture. This entire thing is a very cool exercise in software architecture, that you have a module that is completely independent from the output, not only video output but also audio output, and you can hook it up into different sort of syncs, right? We hooked it up into the rendering the video, which we implemented first, by the way. We first implemented the rendering of the video, and then we hooked it up into the OpenGL Pulse audio, right? So OpenGL Pulse audio probably won't work on Windows because there's no Pulse audio on Windows, but then this entire architecture makes it easy to port this kind of thing to Windows, right? So I would call this entire, experiment a success. Simple bounce. I'm gonna push that right into the repo. All right. I guess this is the last episode in the series, because yeah, it's the last episode of the series, I suppose. Hope the series for 2mpeg4yuv were interesting. Hopefully maybe you learned something more. I definitely learned a lot of things, but that's the final episode. I'm not gonna be doing this kind of shit anymore, that's for sure, because it is extremely tiring. It is extremely tiring. So yeah, thanks everyone for watching. Have a good one, and I see you next time. I don't know when, I don't know where, but I gotta go. Thanks everyone for watching.